look at the Earth today, it's magnificent. It is home to over 8 billion people, thousands of flora and fauna species, millions of bacteria and microorganisms, and also undiscovered animals and aquatic life. But it wasn't always like this. In fact, in the genesis of the Earth's formation, the planet was a hot ball of rocks and gases that could not support life. But then we've all heard about dinosaurs and their existence on Earth 4 billion years ago. Though we don't know exactly what wiped the species out, there have been a lot of theories laid out by scientists and astronomers as they continuously make discoveries emanating from fossils and the chemical compositions of rocks and other things. So we do have an idea that the Earth was once habitable. But do we know what the Earth was like before dinosaurs appeared? Or were dinosaurs the first animals to live around that time? In today's video, we're going to find out what the Earth was actually like before human life and the dinosaurs. Are you eager to know how this world came to be? Then let's begin. Life. When we talk about life, we need to know what conditions make it possible for life on Earth. These conditions include aspects like the right distance from the sun, the Earth's magnetic fields that control the tectonic plates, or in other words, the land we stand on, the insulating atmosphere that warms the air around us, and the two most important elements, water and carbon. However, you would be shocked to know that before life even started forming on Earth, our sun was also forming. In fact, the Milky Way galaxy had just begun to take shape. There were no solar systems or even the moon. So, how did the Earth form? Ever heard of the Big Bang explosion? Yes, it was this catalytic action that set the course of life on Earth some 13.8 billion years ago. Because of a collapse in gravity at the center of the cosmic core, an explosion took place that later on came to form our solar system and the Milky Way galaxy. Fun fact, the Milky Way galaxy is still expanding even today, and as there is no gravity holding on to the cosmic matter in space, celestial bodies, asteroids, and other space debris are still moving away from the point of explosion. But anyway, let's go ahead and get back to our galaxy. This phase of the formation of our solar system is called the core accretion scenario, because it was at this time that our universe was merely a whirling, chaotic soup of hot gas and dust. The matter began to rotate more quickly as the nebula shrank. The developing solar system consequently shrank and flattened into a disk. Due to gravity's compression, the center of the dense cloud became extremely hot and heavy. This evolved into the sun. The solar winds were so strong that they pushed the material on the periphery of this nebula out into space. With the help of gravity, the matter has gathered into what is known as protoplanets and potential moons. This is how the Earth formed. The Earth was the third protoplanet from the Sun. The early stages of the Earth. The Hadean Age. The Hadean Age means the underworld in Greek, and it was considered so because the Earth could not support life during this time. According to scientists, when the Earth formed, it had extremely high temperatures because of the increased pressure caused by gravitational compression. On top of that, it also suffered the consequences of meteors and ongoing radioactive decay. Initially, the Earth was largely made of liquids, rocks, and gases. Dense and light liquids like oil and water separate from other metallic liquids to form land masses and oceans, while the denser metallic liquids sank deep into the core of the Earth. When the rocky lands formed, the tectonic plates of the lithosphere formed the volcanoes and Rocky Mountains, and as a result of the continuous meteor and comet showers, the Earth had a hazy atmosphere that consisted of gases like hydrogen sulfide, methane, and 10 to 200 times as much carbon dioxide as today's atmosphere. The comets that fell onto the Earth were relatively ice cold, which then slowly condensed to form water vapors that turned to clouds and then rained. This effect helped the atmosphere form while lowering the temperatures. As a result of this, oceans started developing, and slowly gases like nitrogen and oxygen started to form. Our natural satellite, the Moon, was also in its early phase of formation during this time. It was thought to have formed from the Earth's colliding with Theia, another protoplanet. This was also termed the Giant Impact Hypothesis. The Archean Age. The Archean Age began 3.8 billion years ago after the Hadean Age ended. Archean means beginning or origin in Greek. Why? Well, because it was during this age that the Earth showed signs that it could support and sustain life. The first signs of plate subduction and the expansion of microbial life are found in the Mesoarchean Age, which is part of the Archean Eon. During the Mesoarchean epoch, microbial life with a range of metabolisms developed and generated gases that affected the composition of the Earth's early atmosphere. Oxygen gas was created by cyanobacteria, but it took until later in the Archean for oxygen to start building up in the atmosphere. The Proterozoic Age. This was where the Earth's crust started forming, creating supercontinents like Rodinia, Pannotia, Pangaea, and Gondwana. These supercontinents took millions of years to form the 7 continents that we know of today. And when we talk about life on Earth, it all started in Rodinia, with the formation of the first eukaryotic cells. Though life on land was not possible, considering that the ground reached temperatures of 1600 degrees Celsius, life in the sea was flourishing. Aquatic life began to develop from simple cell structures as single-cell life progressed. Microorganisms, decomposers, and other life forms began to emerge in this period, but they were mostly restricted to water. With the breakup of Pannotia and Rodinia at the age of the Proterozoic, there were 2 major extinctions during this time due to a change in plate tectonics, which led to the formation of the supercontinent Pangaea. The supercontinent covered about a third of the surface of the Earth. Pangaea is derived from a prehistoric Greek word that means all lands. It was Alfred Wegener who discovered that the continents of the Earth resembled pieces of a jigsaw puzzle when he coined the phrase. Over time, this term came to be known as the modern study of plate tectonics. The formation of Pangaea supercontinent is important as it started the Phanerozoic Age, which was also termed the evolution of life phase. After the end of the Proterozoic Age come the Phanerozoic Age, which began around 538.8 million years ago. This age was an important phase as it created the evolution of life. Fish with bony fins were first formed, followed by reptiles, land animals, and dinosaurs. It happened gradually over the course of 3 eras, the Paleozoic, Mesozoic, and Cenozoic. The first plant life appeared on Earth during the Paleozoic, which spanned from 538.8 to 251 million years ago. Following this, animals began to live on the planet. The Mesozoic lasted from 251 million years ago to 66 million years ago. This age makes up 3 eras: the Triassic, the Jurassic, and the Cretaceous eras. It was during the Mesozoic Age that the first land animals were discovered to have lived on Earth. The first arthropods and tetrapods were the first to evolve from sea creatures to land creatures. Land creatures then evolved to form land mammals, such as dinosaurs. But towards the end of the Cretaceous era, there was a mass extinction, wiping out 95% of life on Earth. Though we don't know what caused this, scientists are still researching it. This era was termed the Permian-Triassic extinction catastrophe. And finally, the Cenozoic era, or the era of new life, began 66 million years ago. Although it was believed that asteroids or comets were to blame for the mass extinction, other mammals such as birds, amphibians, crocodilians, turtles, and lepidosaurs managed to survive the Cretaceous-Paleogene extinction event. The evolution of species into the animals we know today was further enabled during this era. And there we have it. This was the Earth's life before the dinosaurs. And we all know what happens next. Mammals began to evolve, followed by the evolution of Homo sapiens, the Great Ice Age, and consequently the start of civilization. But to think that this all began from the mere collection and collapse of gases and dust would boggle anyone's mind. What's more interesting is that the Earth formed particularly just right to support life. Though we will still know relatively little about how Earth's chemical makeup before it was formed and the contrast of it to other planets, there is still a lot that we need to learn. I hope you enjoyed this video. If you liked the content, then hit the like and share buttons below. You can also leave your comments or thoughts on this video in the comment section below. Don't forget to hit the subscribe button and bell icon so that you don't miss out on any of our new uploads, and thank you for watching.